Hi students, in this lecture I am going to discuss refraction through a parallel slab. Let us see what is it. So consider a parallel slab which is a transparent. So this is a slab which is a transparent. Let us take a point object which is real. So we are taking a point object which is real. At some distance, take it as x. So I am taking here a point object that is, so take it as O. Its distance is equal to x. Let us take this is A and this is B. Distance of object from A is x. Now see, since object is now real, rays are now diverging from here, means like this, like this, like this, in all directions. Let us take now one light ray. So light ray is now instant on the slab. It is now incident on the slab. You can see here, if you imagine a normal at the point of incidence, this will bend towards normal. Reason is that it is entering into denser medium. That means it is now slightly bending towards normal and goes like this. Now what I'm doing here, I'm just extending now this light ray back. Just extend now this light ray back. See carefully. Extending that light ray back. Let me draw once again this extension back. So when we extend that light ray back, the point of the point where it meets this line, that will be image. This is now image of this point. So take it as I1. See what we are doing here. First, we have taken an object O at some distance from this face, that is x. When this incidents on this face, this will undergo refraction. Now this light ray bends towards normal. When you extend this back, that will meet the line at this point. So if you imagine there is a person inside the slab. So for him, these rays appear to come from this point. Okay. That means because of this refraction, image is now I1, right? That means we can say clearly AI1 is more than AO. So how many times means it is mu times of x. So this is what we have learned in apparent depth, right? Because traveling from rarer medium to denser medium. So AI value means AI1. So AI1 is equal to mu times of x. Now after refraction, rays are falling on the other face. That means this image I1 is acting as object for this refraction. I am repeating, this image I1 is acting as object for this face because rays are falling on this face. And you can see here, this light ray will bend away from normal because entering into a radar medium, right? So it is now bending like this. Okay. Now extend this rays back. So extend carefully to make a diagram. So extending that light ray back. So when a person sees from this medium, for him, these rays appear to come from this point. So let me take it as I2. So I2 is image of I1. Okay. So see what I'm doing here. First of all, we got AI1 is mu x. Since we are taking refraction from the surface, we should measure now distances from the same face. So from B, distance of I1. So BI1 is equal to BI1 is equal to, see how much? It is AI1 plus its thickness is now T and refract index is mu. Okay. So BI1 is equal to AI1 plus T, that is mu x plus T. Okay. Now see carefully. Distance of I1 from B, mu x plus T. When light rays are coming from denser medium and entering into rarer medium, that distance appears to be 1 by mu times, right? So this is what we have learned while discussing apparent depth. Therefore, BI2 BI2 is equal to 1 by mu times 1 by mu times BI1, that is equal to, see how much 1 by mu means, it becomes x plus T by mu. Okay. Now see its distance from A. We got BI2. I want to find out distance from A. So AI2 is equal to BI2 minus T, right? BI2 minus T. This is now x plus T by mu minus T. Okay. Now see what we get. So we want to calculate. Initially, the object was at a distance x. But for a person who is now in this medium here, for him, these rays appear to come from this point. That means after two refractions, image is now formed at this point, image of O. So for him, rays appear to come from here. So this is just like object for him. Okay. So how much distance it has shifted? See carefully. Shift equal to it is AO minus AI2. That is now shift. AO means x minus AI2. AI2 is now, it is x minus t plus t by mu. Okay. So x gets cancelled, minus of minus of plus. It is a t into 1 minus 1 by mu. Students, see carefully. Shift is now t into 1 minus 1 by mu. And this is not depending on distance of the object from the slab. So first condition is, this is not depending on distance of the object from the slab. Second thing, this is now shifted in the direction of light rays. Light rays are traveling towards right side, instant light rays. Shift is in the same direction. So one conclusion, this is not depending on location of object. Second one, this shift is in the direction of light rays, means instant light rays. And next one, When object is real, finally see what happened. Rays are diverging. Means if I'm taking here one more letter like this, one more, finally rays are diverging like this. That means image will be virtual. If object is real, image will be virtual because after two refractions, rays are diverging, right? So if object is real, image, image is virtual. Okay, let us now discuss. If object is virtual, then see the points once given here. Shift is in the direction of instant light ray. If object is real, image is virtual. This is what we have discussed, right? Let us see now if object is virtual, image is real. Let us make a diagram for this. Right, make a diagram for this one. Now object is virtual. Object virtual means instant beam is converging beam, right? If instant beam is a converging beam, then object is virtual. Right, let us take here one line. Right, let us take now light rays. A light ray is now incident like this. This is now a converging beam, okay, like this. A converging beam falls on the slab, okay. Now focus carefully. If you draw normal, instead of going straight away like this without deviation, it bends towards normal because these are now entering into the denser medium, okay. So light rays, let me take it now. If light rays are bending like this, so it is, okay. Let me make a diagram once again. So first of all, we have to focus. So where these light rays are meeting, okay. If you are not having a slab, if you are not having a slab, where light rays are going to meet. Let us take a light ray instant here. This is a converging beam. If there is no slab here, it is supposed to converge here. That is now object, or you can say virtual object. Okay, means if there is no slab, these rays are going to converge at this point. Now, because of refraction here, see what happens. Because of refraction, let me make a diagram. So it is now because of refraction at this face. Okay, I am drawing here. This is image 1 because of refraction 1. Students, remember that O is now no refraction, means no slab. If no slab, rays will converge at this point. So let me take this as A and this is B. Suppose now distance of virtual image from B is X. Okay. Now because of refraction at A, means from this face, rays will converge here and here no refraction. Okay. Next, now this is image, means image of this point because of first refraction. But after coming here, again medium is changed. Since medium is changed, it is again refracting. So after refraction, you can see they will converge now. So let me take a different color to make it clear. Right here again, refraction. Let us take, they are converging somewhere here in between those two, and see how we are knowing this. Because if you imagine here a normal light ray is entering now, radar medium, it bends away from normal. That means it has to converge before I1. Okay. Now let us see distances. First, we are focusing diffraction at this phase. That's why measure distances from this phase. So from a distance of object, this thickness is a t, refract index mu. So first I'm taking distance AO. AO how much means from BX, from A, X plus T. So I hope you are getting it. Next. Now it is converged at I1, right? Because of the first refraction. So distance is now more. How many times more means it is mu times. So I can write directly AI1 is equal to mu times of X plus T. Okay, right. After having refraction here, rays are falling on this boundary. That means I1 is acting as object for this refraction. And for this object, image is now IT. So since we take refraction from this face, we should take distances also from same face. Okay. So from B, distance of I1. Okay. So from B, distance of I1. So BI1 is equal to so BI1. So we know AI1, right? AI1 is known, that is mu times of X plus T. So mu times of X plus T. Mu times of X plus T. From that, subtract now T. That is giving us distance of I1 from B. Right. Now focus here. What is now BI2? BI2 is less than BI1. How many times means 1 by mu times. So BI2. So BI2 is equal to BI1 by mu. Right? BI1 by mu. See how much? X plus T minus T by mu. Because we are having here BI1, right? So by mu. Now focus what is a shift. Okay. Shift equal to how much? Initially distance was X. Now it is BI2. That means shift is BI2 minus BO. So BI2 X plus T minus T by mu minus BO, that is X. It is now T into 1 minus 1 by mu. Students, remember in the earlier case also we got same result. See key point here. Light rays traveling now towards right side. Shift also right side. That means a shift will be in the direction of instant light ray. That's one important point. Second point, here it is now converging beam. Converging beam means it is now a virtual object. And we can say finally rays are really converging. Finally rays are really converging. That means image is real. So when object is virtual, image is real. So these are the key points which we have to keep in mind. Okay. Let us see now key points here. So in both the cases, shift is in the direction of instant light ray, right? If object is real, image is virtual. If object is virtual, image is real. Okay. Let us focus one problem to get a clarity. A point object O is placed in front of a concave mirror of focal length 20 centimeter. A glass slab of refractive index n equal to 3 by 2, n equal to 3 by 2, and thickness 6 centimeter is inserted between the object and mirror. Find the position of final image when the distance x shown in figure is 35 centimeter and 65 centimeter. Okay, let us see how to solve it. So first make a diagram, that given diagram. So there is a concave mirror, concave mirror, and there is a slab. See what is the thickness given? Slab thickness 6 centimeter. Its refractive index is 3 by 2. Okay. So first let me write shift equal to. What is a shift? Shift equal to t into 1 minus 1 by mu. T values 1 minus 1 by mu value 3 by 2. 1 minus 2 by 3. 1 by 3. 1 by 3 into 6. That is, let me see once. 1 by 3 into 6, right? Okay, that is now 2 centimeter, right? Okay. Now focus carefully. Given that an object is placed in front of a concave mirror of focal length 20, glass slab given, thickness given, object, and you are given here distance of object is now 32. This is now object. Its distance is given 32 centimeter. Right. So rays are falling on this slab. It is now real object. Now see what happens. After having two refractions, means if we observe from this side of the slab, for us rays appear to come from somewhere here, and that shift will be equal to 2 centimeter, right? See carefully. When we see from this side, rays appear to come from here, not from here. Or we can do like this. Because of this will shift by a distance 2 centimeter, right? Then rays are falling on the mirror. That means now distance of object from the mirror is 30, not 32. This is what we have to keep in mind. Next thing, we have just now learned after refraction, rays will diverge. That means this is acting as a real object because after two refractions, rays will diverge. Yes or no? When object is real, they are diverging. Diverging means falling on this one. So this is acting as a real object. Distance equal to 30 and given focal length equal to 20. So let me find out what is V value. 1 by F equal to 1 by V plus 1 by U. Taking sign convention, light is traveling towards the right side. So right of the pole is positive x-axis, left of the pole is negative x-axis. So U will be negative and F also negative. Okay. So it is minus 1 by 20 equal to 1 by V plus 1 by minus 30. Okay. Then see what we get. 1 by V equal to 1 by 30 minus 1 by 20. 1 by 20. So V value how much? 30 into 20 upon 20 minus 30 minus 10. It is now minus 60. Minus indicates it is a forming a real image. Okay. But remember, when they are converging after reflection. So you're having here a diverging beam like this. Diverging beam. Now they're converging after reflection because we got negative. They are converging. Now focus here. Distance x. Distance x. In case 1, x value given 35. Second case, x value 65. Right. See what is the meaning of 35. If we are not having this slab, image must form at a distance 60 centimeter from the mirror. But before converging, before converging, they have to pass through the slab. Means again two refractions. Okay. I will make a diagram here once again. This is now mirror. Image must be somewhere here. That distance how much? 60. It is a converging beam after reflection, that converging beam. When converging beam falls on the mirror, finally rays will really converge, but since rays are traveling left side, shift also left side. That means instead of converging here, it will converge now somewhere here. So take it as I dash. And this is shift equal to 2 centimeter. That means finally image will be real because converging beam. We have just now discussed, right? If a converging beam falls on the slab, they will really converge. They will again converge, but at a distance 62 centimeter from the mirror. Okay. So we have to keep in mind here any value, any value less than 60 on the same. See what it means. Any value less than 60 means converging beam falls on the slab. Okay, less than 60. Second one, any value that is greater than 60. Need not be 65. It can be any value greater than 60. See what happens. I will make a diagram separately here. This is for second case. Image forms at a distance 60. This is I. Distance 60. But remember, now where is this? What is x? X is given 65. This is now slab. Okay. This is now real image. So after converging, image formed at that point after converging. Now again from here, this is acting as object for this one. Again rays are diverging and falling on this one. Okay. Now this time diverging beam falls. See carefully. This time diverging beam falls on the slab. When it is a diverging beam, finally rays will diverge. Okay. So I'm making diagram for this one separately once again. This is mirror. This is image I. Now what happened is rays are traveling towards right side, diverging beam. Finally, rays will again diverge after two refractions and image forms here. This is I dash. In both the cases, location of image same. Only changes. This is real image. This is virtual image. That is the only difference. Because in this case, converging beam falls on the slab. In this case, diverging beam falls on the slab. So this is a real image. This is virtual image. Location is the same. distance equal to 62 centimeter from the concave mirror. Okay. So I hope you got a clarity.